This video we're going to be talking about imaginary numbers. Okay, so consider the equation x squared. How do you undo squaring a number? You square root it to undo it. When you solve x squared equals 2, how many answers should you have? You should have 2 answers because you have the positive side and the negative side of it. How many x-intercepts does the graph x squared minus 2 have? It should have 2. Okay. So solve the equation x squared equals 2. Write your solutions both as radicals and as decimals. So x squared equals 2. We square root both sides. X equals plus or minus the square root of 2. Or 1.41. Okay, so definition, rational numbers are numbers that can be written in the form of a fraction. So I've got 2, 1/2, 0.3, 0.75. Okay, irrational numbers are numbers that can be expressed as terminating or repeating decimals. So the square root of 2, e, and pi. Okay, they never end. Okay, are some equations not solvable? Let's take a look at y equals x squared plus 1. What are the x-intercepts of the graph? Can you solve it algebraically? Okay, so if you graph it, it's going to be 0, 1. So 0, 1, right one up 1, right one up 3, left one up 1, left one up 3. Okay, so there are no x-intercepts. Okay, let's go ahead and solve it. So I'd subtract 1. I got x squared equals -1. Opposite of squaring is square rooting. And what we have been taught is that you can't square root a negative. Well, what I'm going to show you is how to keep solving the problem by using imaginaries. Okay, so we're going to be able to pull that negative out of the square root by using a little I to tell me that there is a negative square root. Okay, so in the 1500s, an Italian mathematician named Raphael invented the imaginary number. So the square root of -1 is I. Okay, so we can also do a bunch of different things with this. This is the main one you want to know. Okay, I've got this I cubed, which is I squared times I. Okay, when I rewrite I squared represents -1 because if I square both of these here, it becomes I squared equaling -1. And we still have that times I. Okay, so this would get me -I. I to the 4th is I squared times I squared. Well, we already established I squared means the same thing as -1. So -1 times -1 will get me 1 for this. So the big thing to remember is that I represents the square root of -1. And then if we square both sides, I squared equals -1. Okay, so if I wanted to separate this the long way, so I've got the square root of -1 times the square root of 4. I said this represents I. And then the square root of 4 is just 2. So now it's like we can take this negative out of the square root by putting my I, or my imaginary, in front of it. Okay, so 2 times 3 gets me 6. I times I gets me I squared, which we already know represents -1. So my answer for that one is going to be -6. Okay, my square tells me there are 2 of these, so I'm going to go ahead and write it out twice. And then multiply all my coefficients. So 2 times 2 gets me 4, times -5 gets me -20, and then I group them in 2's, so I've got I squared times I, because I can change that I squared to a -1 pretty easily. So -20 times -1 is a positive 20I, and that I is just going to have to sit there. Okay, we can pull this out by putting an I in front. Square root of 25 is just 5. If we are solving, then we would get the plus or minus. Okay, I times I, so 5 times this negative is -5. I times I gets me I squared, which we can change to -1. So I just get 5. This one, if I multiply what's on the inside here, I would get 12. So 4 times 3 gets me that 12. Square root of 576. Okay, which if I simplify that and multiply by 12, I'm going to get a pretty 288. Because I can simplify what's underneath square roots, I can just multiply those. So it's a lot easier than pulling out I's and making it really long. Okay, multiply coefficients, I get -20. I times I is I squared. I squared represents -1, so I get a positive 20. 2 means there's 2 of them. Multiply my coefficients to get 9. I times I is I squared, which becomes negative 1, so negative 9. Okay, this should automatically equal I, so if you take that negative out, we would have I times the square root of 1. The square root of 1 is just I. We write this one out twice, so I don't leave anything off. So negative 3 times negative 4 times negative 4 is going to get me negative 48. And then we group these in twos. So I squared times I, because I squared I can change to a negative 1. And then when I multiply those, I get a positive 48i. Okay, we get this negative out by doing an I. Square root of 36 is just 6. So 6i. We write it out twice. Negative times a negative is a positive. I times I is I squared, which then changes to negative 1. Okay, complex number. A real number plus or minus a multiple of I is called a complex number. Complex numbers are written in the form of A plus BI, where A and B are real numbers and I is the imaginary. Okay, so examples of this are 2 plus 3i. We could have 4 minus 5i. So we have imaginaries and reals mixing for complex. Okay, so my first step in this is to look to see what's in between it to see what I do. Plus means it's not going to change anything behind it, so we can go ahead and add our like terms. So 4 plus 1 is going to get me 5. Negative 3i plus negative 5i gets me negative 8i. Remember, when adding and subtracting, pretend they're like x's, like negative 3x plus negative 5x. It doesn't become x squared unless we're multiplying. So just combine. Okay, this negative is going to have to distribute. So I got negative 3 plus 7i. Negative times a negative is a positive. Negative times a negative is a positive. And now we're going to combine our like terms. So negative 3 plus 1 is negative 2. 7 minus 6 plus 5 is 6i. Okay, I look to see what's in between. It's a plus sign. It's not going to change anything, so I can go ahead and combine like terms. That's the only one that I can combine, so I get 5i. Okay, minus, we have to distribute him because it's going to change everything behind him, so it becomes a minus 7 minus 2i. So 12 minus 7, we get 5. Negative 3i minus 2i is negative 5i. So always check to see what's sitting in between your parentheses to see if something needs to be distributed. Because this one is a multiplication sign. So I either box, FOIL, or distribute. Okay, if I FOIL, my first is 4 times 1, so I get 4. Outside, 4 times negative 5i, so I get negative 20i. So you just multiply those numbers, 4 times negative 5. Inside is negative 3i times 1. And my last is negative 3 times negative 5, which gets me 15. And then I times I gets me I squared. We can combine in the center here to get 23. And then my I squareds always change to negative 1s. So he will become a minus 15. So I get negative 11 minus 23i. Okay, my next one, we're going to write them out twice. And FOIL. So first, negative 2 times negative 2 is 4. Outside, negative 2 times 3 gets me negative 6. We just keep the I with him. Inside, negative 2 times 3 gets me negative 6. Keep the I with him. And my last 3 times 3 gets me 9. I times I is I squared. Okay, this will get me negative 12i plus I squared changes to negative 1. So really it's a minus 9. So I will get negative 5 minus 12i. Okay, my next one here, multiplication sign in the center, so we're going to FOIL again. Negative 3 times negative 1 is negative 3. Negative 3 times negative 5 is a positive 15. We stick the I with it. Inside, 2i times 1 is 2i. And my last 2 times negative 5 gets me negative 10. I times I is I squared. So I get 17i in the center. I got negative 10 times negative 1, so it'll change to a plus 10. So I get 7 plus 17i. Okay, my last one here, multiplication sign in the center again, so we're going to FOIL. 6 times 1 is 6. Outside 6 times 3 is 18. Attach the I. 2i times 1 is 2i. Last 2 times 3 is 6. I times I is I squared. We get a 20 right there. And we change him to a negative 1. So 6 plus 20i minus 6. So really what we have left is 20i.